everybody. Today I am here to take the class of standard 9 and my topic is work, power and energy. So let's start the class. Work means doing something in our day-to-day life. Okay. Suppose a gateman guards a house all day long sitting at a place, and he can say that he did a lot of work, isn't it? But in the language of physics, it is not a work. Look, here I have drawn three figures. Okay, one girl is standing holding a bucket of water. Then a boy is trying to move a stone. And in figure 3, a force F is applied on a ball and the ball is displaced at a distance S from its initial position to final position. So, can you tell me in which figure in the language of physics work is done? Yes, in the figure 3, because here force is applied on an object and as a result the object moves from its initial position to final position. But though she is applying force, the boy is applying force, but work is not done here. Okay. Suppose the girl is standing here holding the bucket for 2 hours. You can tell lot of work is done. Yes, in the day-to-day life we can tell it as work. But in the language of physics, she has done no work. And the boy has done no work as the stone is not moved at all. But here the ball is moved from its initial position to final position. So here we can tell work is done. So what is work? Look, I have written the definition of work done. When force acts on a body and causes displacement, then it is called work. So work equal to what? By the formula for work equal to force into distance travelled along the direction of force. We have to clearly understand here work equal to force into distance travelled where along the direction of force. So let's erase the board. Okay, everybody, look here. By applying F force on a box, the box is moved a distance S along the direction of force and it is displaced from its initial position to final position here. So here work equal to what? Force into displacement, that is F into S. Now we can find out the unit of work. Okay, unit of work. Unit of work is called joule. You know the unit of force is what? Newton. And unit of displacement is what? Meter. So Newton into meter equal to, we can here just give dot. Newton, that means also multiplication. Newton into meter equal to what? Joule. So if I tell you what do you mean by 10 joule work, that means 10 joule work means 10 Newton force is applied and as a result 1 meter displacement occurs. So that is 10 joule. So this type of significance can come into your exam as B number question. Okay. And I will also explain you how to calculate the dimension equation of work. Work equal to force into displacement, isn't it? But force equal to what? Mass into acceleration. MA. MA into S. M, that is mass. Its dimension is capital M. A, that is acceleration. Its dimension is L T inverse 2. S, that is displacement. Its dimension is simply L. So the dimension equation of work is what? M L square T inverse 2. So we get what? The unit of work is joule and the dimension of work is ml square T inverse 2. Action. So from figure 1 you can understand how to calculate work done. Now from figure 2, sometimes it happens when F force is applied on an object but the displacement is occurred by making an angle theta with the direction of the force. But work equal to what? I have told you, force into distance travelled along the direction of force. So This is the component of displacement along the direction of force. So the work according to this figure will be what? Force into the component of displacement along the direction of force. Look, F force is acting along this direction. So the displacement that is along the direction of this force is what? OB. So we have to calculate this OB at first. Here you can see F force is applied and the body is moving by making an angle theta, moving towards O, traveling S distance. Okay. So if I draw a perpendicular from A to OB, then this angle is what? Cos theta. Because you know cos theta equal to what? Base by hypotenuse. F into S cos theta. How does this come? In the rough work I have shown you, I am showing you cos theta equal to OB by OA equal to OB by S. So OB equal to what? S cos theta. Do you understand, everybody? We need to find out OB and we got here OB. So when force is applied on an object and the object moves by making an angle theta with the direction of force, then the work done will be Fs cos theta. I will show you some math depending on this formula also in the next class. Let's see this.